it says I'm offline. No, there we go. Okay, so let's just continue where we left off here. So we were working on, yeah, persistence of the logical devices that has state, like buttons, doors. Well, we don't have buttons yet in the game code, but doors and the toggle devices. So yeah, basically, yeah, we want to store them both in like the save file and also during, like, in memory during like scene transition stuff. So I was working on this, and then I added, now I'm adding cbor encode and extract functions to the ID or the UUID struct that I have, because it didn't work with well, writing a U128 didn't work with cbor, so you have to split it up in stuff. And I thought that, okay, maybe I can split it up in a U6 in U8s, like just a string of bytes. But then apparently when you read an int, the cbor thing only matches, wait, no, when you write a value here, it can only write U64 or I64s. So yeah, but it is kind of fitting because we just need two U64. So what we want to do is we want to say, I'm just gonna say write value, and the value is gonna be, so that's gonna be self UID, but yeah, this is 128, so we need to make it into a U64. Now I'm gonna first write the first part, so I'm just gonna do an int cast as a U64, which will basically, as far as I understand, I think this will do is it will just truncate, or well, it will just cut off the the first part or the largest part, so it will only take the lowest part of the U64 here, I think. Let's hope, anyway. And then we'll see what happens. And then what you want to do is, I want to do this. So this will shift 64 to the right, or it will shift 64 times to the right, which will take the highest part, put it in the lowest part, and then we cast it into a U64. So yeah, so let's read on int cast here. Converts an integer to another integer while keeping the same numerical value. The return type is the inferred result type. Attempting to convert a number which is out of range results in a safety checked illegal behavior. Okay. To truncate the significant bits of a number out of range of the destination type, use truncates. Okay, so let's do truncate then. So this function truncates bits from an integer type, resulting in a smaller or same sized integer type. The return type is the inferred result type, right? So this function always truncates the significant bits of the integer regardless of endiness of the target platform. Okay. Yeah, so I think it means it will just cut off the the higher valued bits, so to speak. Yeah, so this should be good. Like truncate. So returning a U128 to two U64s. We're writing those. And then we want to read them here. So we're not dealing with an array anymore. Let's just remove all this crap here. Well, we want to do, let's do this. So let's read the first. First is going to be cbor match int. And this match int will wait, integer, negative integer. Okay, I'm not sure what's going on here, but I'm pretty sure you should be able to match like this. So I want a U64 and use this iterator here. The value, oh yeah, so we'll do this. This is undefined. The value is first. We'll put the value in there. And then for this one, we'll do a try. And then we'll also check if this is returns false, then it means it didn't match the thing. So we'll just return false. And then we want to match another int. And this will be the second U64. Alright, so match another one. So the first one is the higher part, and then the next one is the lower part. So I'm gonna label them with higher, or high, I guess, high and low. Okay. And then what we'll do is we'll say self dot uid. So because this is a pointer, then this will modify, I think this will modify the pointer here. So this will be not that. This is gonna be high 64, but I think we need to convert this to a U128 first. And then we will int cast. Okay, and then we'll shift it. And then we'll add, which I guess we can use, technically we can use an OR operation here. And we just OR it with low. So that will reconstruct our U128, I think. All right. Because, yeah, the low, I'm not sure, I think Sig will work it out. Even if this is not the same type, it's a U64, but it should work, I think, here. Yeah, I don't get any compiler errors anyway. All right, so yeah, so that should be that. Now we're reading to U64s. Okay, let's just see if this works. So we'll go over here, we'll load the thing. All right, let's start this one. So we'll open that up, go up here. It won't work, but that's not the issue that we're looking at right now. And oh, we don't have leaks. Okay, so now we'll check the map key type. Oh, okay. Okay, so before we got invalid UTF-8, now we get could not decode map key type. So apparently the thing is not supported here, like the U128 is not supported as a key, I guess. Okay, so it is sort of encoding it as a map, but then the key type has to be encoded. Okay. Well, okay, so all of this was, so this is like encoding as a U128, but actually we want to do write string. So we want to actually serialize the UUID here. Wait, I thought we had a method for that. Well, it's gonna be UUID earn serialize. So that's UUID. So that is the value that we want to write. And yeah, I guess we can. Does it work with arrays actually? Arrays child, yeah, it just writes the string, yeah. So we could also pass it like this, like a pointer to this, but yeah, let's just do that. All right, so we're just writing it as a string, I guess, to make it work with a map for CBOR. All right, and then we'll do the same thing here. So this is actually now decoding as a U128 or as two U64s. This is decoding as two U64s. I guess we can keep those as well, actually, no. Let's just remove it. Fine. All right. So what we want to do is we basically just want to read a string now. So we'll create a ID here. This is gonna be undefined. And then try CBOR match string. Okay, use this convention here. Value is ID. Right, and now the strings, we don't need an allocator, so the ID is gonna be sort of tied to the source. But it doesn't really matter because the ID is, but it's going to be temporary here anyway. So now, well, we do want to return true. We want to check also if this is false, we return false. But if everything goes well, we're down here, and then we'll say we will populate ourselves with UID earn deserialize this here. There we go. Wait, expected. All right, so, well, okay. Can we do try, or will that be a different error now? Because yeah, no. So we cannot actually use a normal try here. We have to basically catch and return false here. All right. So if the deserialization goes wrong, then there's something wrong with the data here. So we return false. Actually, then we do need this as a separate thing. So we do need this to be this, and then we'll use you like this. Now if everything goes right here, we will say this is equal to this. All right. So there's basically like a rollback. If something goes wrong, we roll back the iterator. All right. There we go. Okay, so let's try that now. All right. Same procedure as always. Invalid key. All right, so yeah, I need to look at the thing here. Okay, there we go. Now we see the map here. So this points to an entity. Now let's just check if this is the same as we have here. So I will open up a new tab here, terminal. Now we'll just search for this. Oops, that was wrong. I always do this. Error. Okay, there we go. So if we search for this, we don't find anything. All right, I think it's like ignoring this here. So there we go. There you can see we have the ID there. Yeah. So this is in the file forced entrance to scene. So it is referring to a specific entity in this scene. So it basically says that, okay, this entity here, which is well, it's something. It's let's see, entity reference. Oh yeah, I think this is the toggle actually. It has activates and property entity reference. Yeah. So, but I am curious because we should also store the door. This only stores the toggle then, but it does store it. So now whenever we launch this again, the toggle should actually be on. It's not. So something is wrong with that. Also, when it's saving here, okay, maybe something is wrong with the restore and the save. So let's check the persistent state. Right, so when we're storing, we're basically checking here, like, okay, what's the initial state? Is it open or closed? Well, that's for the door, yeah. And then if we should save the state, that's saying, okay, is it open? And if it's not initially open, then we want to save the state to open. If it's initially open and the door is closed, then we want to also save that. So should save state is true if we need to save the state because it's different from the initial state. If it is true, then we get or put the entry. So either it's already there or we create it and we set the state to the new state. Otherwise, we shouldn't save the state, which basically means if it exists, we should also delete it because we don't need it, because it's the same as the initial state, which is what the state is going to be anyway when the scene is loaded. So we can just remove it from the map. Here we have toggles. Oh, I see. This should be toggles here. Okay. So that was one error there, but it feels like that shouldn't be the only error. It feels like the door should exist anyway. But maybe since it wasn't restored properly, it saved as being off. So I wanna do an experiment. So let's start here, and let's see if we open, then we transition, or actually let's do this. I'm gonna open this. I'm gonna save it as this, and then we'll check here. Okay, so it still says the same thing. So maybe something is wrong with the save part. Maybe it only stores. I will definitely save both. But now the toggle should be on. So what happens if we start the scene now? It's not on, right? So something is wrong with that. And what does the save say now? It still says on there. Right. Okay. Well, let's look at restore then. Restore devices. So we're looking at all devices that are in the scene, and we're checking for their type here. If it's a door, we're looking for the entry in doors. If it's a toggle, we're looking for entry in toggle. Wait, what are we doing with entity? Right. Wait, am I doing this correctly? So we're looking for, yeah. Because if we don't find the entry with this ID, we don't need to do anything. We just continue. If we do find it, we actually want to set the door state to that. Yeah. But why wouldn't it? Okay, let's do this. Let's log out our state here. Let's start at the save. When we load the save, we're gonna also, I think what we want to do, I want to log out the doors. And the toggles. Oops. Okay, so now those are logged when we load the thing. Let's see what we get from those logs. Because according to Cbor, like the data, the toggle should be on and the door should be closed. So we should have one entry in the toggles map that says that it's on. Okay, why is this taking so long? I really should have a log label here saying it's starting or it's compiling, because I have no idea of seeing that. I guess I could check the logs though, but yeah, here we go. So yeah, so let's just exit out, and we should look at the logs here. So we should have something called doors. There we go. Here's the array hash map. It has entries. Multi-array. Bytes is just a pointer. Oh, okay. Wait, so the length is 0. Okay, so we don't have any doors. Let's look at toggles. This one has length of 1. Right. So okay. So it does seem to load it in correctly there. Well, I guess at least the can I get like entries? How do you get like here's like items, but you need a field. Okay, so there's wait, so can you get like the pair somehow? Pop? No, I don't want to pop. Like, couldn't you get sort of the actual like struct based on an index? Oh, here we go. Get. So you could do get to get the pair out, I guess. But yeah, so anyway. Let's do it here. So let's also do here, so restoring ID. We're restoring that. Let's do it like this, doors, and then we do this should just go in there and grab the layer. Okay. The count, yeah, and then we get I, and then we'll do debug. So the ID into what the state. Let's just do S. So this would be self devices, no, doors, map, value, no, keys I values I, but then it's the tag name because it's an enum value. All right, and I will do the same thing here, except the doors are going to be toggles. There we go. And then over here, we'll remove you. All right. So now we'll get a bit more information there, and then we can also now check. So it's the same state in the save. There might be an issue actually saving it. I'm not sure what's happening, but we'll see here. And if we just quit now, we should see it, I think. No? So it's only like in a transition. Okay, well that actually explains a lot, because this is not called then when you when you like initially load a scene. It's not actually calling this function. So right, it's only calling it from the transition. Which just makes sense, because that was the original purpose of this, was only to work with. Okay, but that actually makes a lot of sense, because what we can do is we can say, we can add the restore function to save instead. Well, restore devices, I guess, because then we don't need to store the thing in here anyway. So let's actually just move this over to the save system. So this would be after all the entities has been created and stuff. We will call this over here. Yeah, this is all good. I think what we'll do is we'll say game temp save restore primitives game registry, game player, sure. And then we also want to do restore devices. All right. And so we'll go back to the save and we'll implement these functions. Okay. Yeah, this makes more sense from a structural standpoint as well. The persistent data is a little bit weirdly named. It's basically just meant to be transitional, like scene transitions, persistent state that is not supposed to be saved in the save. Is basically just supposed to be more like globally saved, let's say, things that needs to be stored between scene transitions, between scenes. Yeah, I need to also double check if we really need that system, because I think it's like storing like animation state or something like that. We'll see what it does. But yeah, so this is the primitive part, and let's remove this. Now this is player, this is the easiest entity. There we go, and then we need self. Okay, and save is gonna be self. There we go. Why does this, like, why is this white and this is not white? I don't understand. Okay, but anyway, that should work. Right, so now this should fill in, no? Oh, because... Right, save. There we go. Alright, so loading the same, we restore the primitives and the devices. Okay. And then here we're restoring what the, so we don't need to do this now, actually. We can just remove these devices here. And we don't even, yeah, we don't need this either. And we don't need to do any of this. Oh, but we need this, actually. We need this in the save now. So we actually need like store devices. Okay. Allocator. Okay. There we go. Oops. Yeah, we don't do this. For this. Yeah, no, we don't do this. Now this is in template save, yeah. Loading the save, we don't care about that. And here we're restoring it. So that should all be good. Now let's check. Yeah, now this is wrong. When we're creating this, we're creating a new save here. So we should actually be using the temp save state here. And if we don't have temp save, we're just gonna say empty. Okay. Now you don't have an initiative, so we don't need to worry about that. There we go. Now we have to call store devices somewhere. And I believe this is gonna be in the transition thing. So game scene. So here we're restoring, that's fine. Yeah, instead of doing all this, what we do is we say temp save dot store devices. So we're taking the we're taking the snapshot of devices that needs to be updated. So basically we're keeping this temp save around as a sort of persistent state of everything. So you load the game, this save state is gonna be kept around for the whole thing. Okay, this might change in the future when, you know, we're gonna have, I don't know what we're gonna do with the saves, but this is how it works now. We keep a save around, and it also has the devices state in it, so we can keep updating with this function here. We can keep updating it. All right, and then basically everything is unloaded. This is a scene transition function. We load in the next scene, which will include restoring the devices and everything there. All right. Now let's double check the save file here. So we should still see it's a little bit inconsistent because this only is on for the toggle thing. The door should also be on, but let's check here. Oh, it crashed. Do we have a compiler error? Okay. Okay, yeah, so we don't need that anymore. Okay, let's see what happens now. So let's just go in, see if the state is restored. The toggle should be on. Well, it's not. So let's go out and see if we get this. Okay, here we can see we actually get this toggle. It says it should be on, but it's not on. So I think what's happening is, oh yeah. So I'm just using the wrong thing. I'm stupid actually. I should actually be using the set state function and not set the state directly. So where is that? It's in, so toggle state. No, this is the wrong project. This is in the save restore devices here. Okay, so let's just remove these logs now. Okay. Actually, did we get restoring? Yeah, so we did get restoring here. Okay. Cool. So instead of just setting the state like this, we should actually call set state, because that will properly handle. I wonder how this works. Does this even work? Like if you do or else continue like this, will that work? I guess we'll find out. The compiler will probably complain otherwise. Maybe. Yeah. Okay, so it seems to not complain. Well, it's not on, so oh, you know what? It might also be because it's set to on. Okay. I think it's because of this. So let's go to our device device code, and yeah, here we call start frame. Start frame will actually if we go to toggle, for example, start frame, it actually resets has changed state. So yeah, maybe we should have end frame instead, because it could be changed from something else. That makes a lot more sense. We should have end frame instead, which sets this to false. Yeah. So let's do that. Let's make it into an end state instead. Yeah, that makes a lot of more sense actually. End frame, and then you will have end frame here instead. Whoops. And I will call this at the end here. I guess we can do defer. Like that. Okay. Because now it's gonna say, oh, the state has been changed. Okay, so let's change it, because it could happen from some other system somewhere. So we set the thing and it checks, okay, so we get in here, the state has changed, so we handle the state change. At the end we end the frame, that will reset the thing, and then something else could trigger the state change, but if we set it at the start, then nothing else can actually trigger the state change. And yeah. Okay, so it still it still is not on. There's no error logs. All right. That is strange. What could that be? Let's take this back. I'm pretty sure calling set state is the play here. Okay, but now we're actually calling this, and also we should say here, we should say new state, or I guess restored state is this. If we have a restored state, we are going to be over here. restored state is tag name restored state. No. Okay, so now we should get the logs for that. Okay, so I mean, it does say here we are restoring the state on, so we are calling that function. So I'm not sure why it's not doing anything. And it should be the original thing here. We're getting the device type out of the entity. This is like the pointer to where it actually exists. Then we're doing this sort of weird switch here where we dereference the value, but we get the sort of mutable version here. And I think this should. So actually, let's do this. Let's say we restore this state. If we get down here, that means we have actually restored some state. So let's also say, okay, what is the restored state that we actually got? And since we know that this is basically a toggle, we can just grab this out from here. Or we can, actually we can do, so we can say new state is device type time dot toggle dot state. Okay, so it does change the sort of original data there. Good. But still, I'm not sure why it doesn't. Oops. Why it doesn't do anything. Right, let me just fix something here. There we go. Whoops. That's the wrong thing. Where is it? There. Okay. So, what is going on? Okay, I'm just gonna see if I have any coffee left, BRB. Now this would be a perfect moment to actually use a debugger, but yeah, it's a kind of a mess setup right now, so I don't want to deal with that. Actually, I wonder if that has improved in the new version. But anyway, so let's go to the device system and we'll check here. So we have update. Oh, but we don't have update door though. But let's check this. And oh, you know what? This might be the issue. So actually, the only updates we're doing is when you hit with a beam here. Okay, that is the issue here. We're not actually. So we're calling handle state change here directly. So we don't want to do that. What we want to do. Well, I guess the problem is when we call handle state changed. We probably, yeah, we wanted to activate other stuff as well. So we call handle state change like immediately. But I guess we don't really need to call it directly here. We could just call it over here. Right? So now it's like yeah, we handle state change even though, yeah, but if it's changed from anywhere. So before we only handled it whenever the lens beam was focused. Okay. Right, that's probably the issue. We'll see what happens. Oh, it crashed, okay. There's some kind of error here. Unused. Okay. Okay, so this doesn't need T, so we can remove that. And don't need T there. Anything else? No. Oh, okay, there you go. It actually, okay, so, I mean, I guess it's, it does handle the toggle in a way. It does sort of, I'm just thinking if this is gonna be a problem, like, because what's happening here is the door did not save the state. It only the toggle saved the state. So when the toggle actually turned on, it's gonna activate everything else that it's connected to, which is the door in this case. So will that be a problem? Because it's not as if the player just opened it. It's gonna actually, I want to just restore the state as is and not like do a bunch of changes. I want to do changes to the state with basically without the chain reactions, I guess. Or yeah, so basically with I just want to change the entity that is this, that the state is changing on. I don't want to change any other entity. That's probably a good way to put it. Because now let's see if I go down. Yeah, so now the door kind of opens. I want it to basically stay, I want it to be open. Also, do we have any errors? Yes, we have leaks. Right, so now we're back to these leaks, and I think I know why they happened, and well, actually, maybe not. Okay, I'm not gonna bother with that right now because it's probably gonna be changed anyway. So let's just forget about it. It's just 2 leaks anyway when you quit the program. Okay, so it's probably gonna be 1 leak per transition or something like that. I don't care about that right now. So maybe we can have a special thing happen for that. So the thing that I want to happen is basically changing the animation of the entity, and that's basically it. That's what I want to happen. So I basically want to prevent other devices to be activated. It's also interesting, I want to see now, does it store the door state? No, it doesn't. So I'm not sure why the door state is not saved. The door state should also be saved here. So that's also a problem. Also the door, why doesn't the door not have a update function? It should. It should have like update. Oh, I see. I know what the issue is. Because the door does not have an update function. So it never changes state from closing to idle closed. And from opening to idle open. So we have to have a door, update door. Okay. Right, and we want to switch on door state, and if the state is, why am I not getting this? Right, so if the state is, let's just copy these. Right. So if the state is any one of these, we don't care. So if it's one of these, we just don't care. If it's opening, we wanna get the state here. And so this should be, okay, so what we'll do is we'll check the animation. So if it's opening or closing, we don't need the state doesn't exist here. So if it's opening or closing, we want to get the animation instance. And if the animation is done, also need T. If the animation is done, then we say device type set state, and then if t is, oh wait, this is s, if s is equal to, so let's do new state just to be clear here. If s is equal to closing, so if it was closing and the animation is done, then we set the state to be closed. Otherwise we set it to be open. So this would be the new state. There we go. I need to pass t here. Okay, so now we're actually updating the animation here. Value with comp time known only, enum in literal depends on time. Oh, does this need to be comp time known? Oh. No field name state in union device type. Oh, this is a state. This is a field type state. Wait. Now this is depending on the current, on the runtime, actually. Oh, so have I not called this function before? I guess not. Okay, let's just say any type then, because I'm not sure if I can actually, yeah, let's say any type. Wait. Okay, I think there's an issue here. I think we need to make like some sort of comp time comparison thing in that case. We could just remove these now, since we know it works. Alright, so maybe I mean we can have this function, it's just that we have to do some shenanigans here, I think. Well, we know the type of state, and then we know which branch this will go in, so I'm not sure why this is happening here. Expected toggle state. Oh, is it because it doesn't know which type it is? Right. So I think we nuke this function then. We just nuke it. Yeah. Right. So we'll just assume it's a door and we'll set it like this. Now this looks bad, but don't care right now. Okay. So the door is now updated. Every frame is checking, okay, are we closing? If we're open or closed, we don't do anything. If we are opening or closing, we check if the animation is done. If it's done, then we set the state to be closed or open, depending on if it's previously opening or closing. So now the state should be saved properly. However, I do also want to change something with how the state is stored, because it should really be saved as open or closed if it's opening or closing as well. It shouldn't only be for open and closed. So I do want to change that as well, because that's gonna be a bug where you can't, like, where you can have a state where the toggle is on but the door is still closed because it hadn't opened fully yet. So so that will become an error. So now this should open when so now this should have state open. So now we exit, we go here, and we check. Oh, it still doesn't say. Still doesn't say open here. What? Okay, let's go to save and let's go to store devices. Right, and then this should also be looking at, like, if the door is open, door state should be open, or door state should be opening. So is open and is not initial open, or is not open and initially open. Okay. But the state should still change though. It still doesn't save it. I mean, it saves the toggle, but it doesn't change, or it doesn't save the door. Okay, I'll check what is the initial value actually of this, or the initial state. It's off. So this is false. This should be true. True, false. Both of those are true. Should save. This should save it. I don't know what's happening. Okay, is there something wrong? Something else? Like, is there something wrong with the restoration stuff? Looks fine here. Well, the restoration doesn't matter because we're not actually. Oops. We're writing doors, we're writing toggles. This is added as a component. That was one I was gonna check. This is always added as a component for all devices. So there's nothing going on there. I guess we can check here. So let's check if okay, what do we want to check here? Yeah, so I basically want to check here, like if we're saving the door state, so door store door, and we'll say this is the entity ID. Is open, should save state, initially open. Okay. Let's do the same thing over here so we can see. Oops. Initially on. Well, is it because it's only called in the transition thing? Oh, it's not even called. So, okay. So we should call this function, the store devices function should be called at the transition, but it should also be called when we save. Right, okay. Here. So, wait. Yeah, we should definitely call it here. If we have a temp save, then we'll grab it out and we'll say, why is this? Why do I not get all the completion here? Save. Okay, there we go. Store devices. There we go. Now it should get updated when we exit the game as well. So let's first we enter Let's exit before the door has time to finish there. There we go. Store door. Okay, okay. And we'll double check the save here. Okay, there we go. So the state is opening. Okay, that's not correct. But it's good that we checked that, because I want it to be open and not opening. So actually here then the door, so it should save state. So the state to save should be so if it's open, we say open, else closed. Let's try this again. There we go. Check the save. Okay, now it says open. Great. And just to be sure here, we also want to test and wait for it to be open. Okay, so that seems to work. It seems to be restored to open, which I guess is fine, but wait, what the hell is happening? But I still want to make sure that we don't have a bunch of weird chain reaction state that shouldn't happen based on this. So we should just restore the state without any chain reactions happening. And in order to do that, when we restore the devices, okay, what now? What if we just set the state here? No, that's not gonna work. Because it's not gonna update animation. Okay, we could do this. We could just add, let's go to devices. We could just add a function here. Where is it? That basically does the animation part, right? So we'll do let's add this to a device type. Update animation. Right. So we'll do the update animation part. So this only updates the animation here. We need T as well. Oh, entity. Yeah, okay. We need entity. There we go. So update animation, and here I mean this is basically set animation, Right, so here we can just say device type dot update animation. And we'll clear this out. And here, no, here, we're doing set animation, animations get initial animation. Now this is basically the same thing. Initial animation looping, T, animation start. So basically this is the same thing, except we do need to add the texture here. So we do need to grab the animation. However, we could just call but then this needs to be mutable. No, wait. We need to grab the device type here. I'm just gonna call it n device type for mutable. And then we can remove you. Yeah. Alright, there we go. And then I think these two we don't really need. Well, okay. Oh, we don't need these. Fine. Alright, anyway, so now we have that function. Now we can go here. And we can say, let's not set the state like this. Let's just set it like this. Well, I guess what we could do. Now, let's just do this. Let's just set the state like this. And we also update the animation afterwards. So yeah, if we get down here, that means we actually updated the states. So that's perfect. So now we can just do update animation. And then we need registry, we need entity, entity. So now we actually need T here as well. Alright. Okay, so this will now make it so that the toggle, when the toggle is activated at the start, it won't actually do like a chain reaction thing. So, well, the door should be open from the start. There, yeah. And so it is gonna be the same thing, but oh, no errors, no leaks. Okay, but if we do a transition, it's probably gonna leak. Wait, why is the... Oh, I see. Okay, the door needs more stuff to happen than just animation then. Right, so... The door, so maybe... Let's see, how state changed? Right. Okay, so actually maybe we just send a bool in here that says is activation enabled or something like that. which is gonna be confusing, but yeah, it's gonna be confusing, but it's what we have right now. So for toggle here, well, we want to check if is activation enabled. If it's not enabled, I think we can just continue. Well, actually, could we just break from the switch? No. Oh, this is not even a... Okay. Okay, let's just return, I guess. And you want... Yeah, okay. So... handle stage change, yeah. So this, from here, we want this to be true. Okay. Actually, you know what? Handle stations. This should actually. We should basically here. We should defer. Switch device type. Well, we should do end of handle state change here actually. Yeah. End handle state changed. So now we do device type and handle state change. Yeah. End frame. Because it's like that could prevent some weird stuff happening where within this chain reaction it's gonna be like it checks, okay, oh, the state still has changed for this, so I don't know, it might not be any difference, but it feels better to have it here. It makes more sense, I think. Right, because now also if we make this public, we can call it from outside and we can say, okay, just we've updated the state, so let's handle this change manually, but we don't want to enable activation and activation. So for it's gonna update animation, it's gonna do the chain reaction here, but if activation is disabled, then we don't do the chain reaction. But for doors, for example, we do other stuff like the collision stuff here. So yeah, it should still do everything except for the chain reaction stuff. All right, or activation stuff. Okay. What is this? Oh, this is the recursive thing, yeah. So you should be true there as well. Now, let's go over to save again. And so here we change the state. We then say system device system, and we handle the state change. And activation is not enabled. Alright, and we'll do the same thing here. Actually, we should just call it down here. Instead of update animation, we just call handle state change with no activation enabled. Alright. Okay, now nothing happens. Well, let's check the... Okay, so the save still says on and open. Oh yeah, so we need to use set state now. That's right. So we do use set state, and because we call this function and this in turn calls end of handle state changed, is actually gonna reset the has state changed boolean as well. So it's gonna take care of this state change at the end here. All right, so let's try this again. There we go. Now you can see the monster now falls down because the collision is correct now. And when we jump up, you can see it properly. Oh, we can actually make this jump here. We have to have the double jump to make this jump. All right. I should move the... Well, I guess you can solve it in two ways, or I mean, infinite number of ways. But it, one thing that makes sense would be to just move the scene entrance up a bit, so you get more of a... You start further up. Another way would be to increase the jump temporarily. Okay, but yeah, that's let's see if we can close it. Okay, so we closed it there. Nice. And now if we exit, we check the save, it should just delete them. Yeah, so if we go back to the original state, we don't need to save that difference. So this is now cleared out. And if we load this in again, it's in its original state. Okay, nice. Now let's make our way. Well, what we can do is we can move up to the tree part here. The background is gonna change here later. I still only have one background that is been repeated for all the levels. Okay, and here we have another quote-unquote puzzle here, which you just opened this one. But I wanted to check if this transition, or if, well, I don't have another thing here. But let's just go up. Well, actually, let's go over here. It's easier, I guess. And then back in. Oh, it's not restored. Interesting. Okay, that's surprising. Let's check the save file. So now that's the previous pair. Okay. Let's start over here. Could it be because we transitioned? So if we do this and then we exit and then we check the save, okay, now it's saved. And let's close it. Exit, check the save, and it's saved. So if we go in, but then we transition, oops, out. So if, let's say we exit now. Oh, so it didn't actually save when we transitioned. Interesting. What Also we have like a couple of leaks here, 2 leaks. But okay, so it's not, it didn't store on transition, scene transition. So the transition is here. We should be storing that over there. Okay. But it did store the other one. The other one is stored properly. Still. So it didn't clear out, you know, the other thing. Like in the other, from the other room. Like the save still has, the other room is saved, which means it's not a case of, you know, clearing everything and not saving it. Because it went from being saved and then on transition it just disappeared. Okay, this is probably a stupid check. I just want to check if the same thing happens at the other one. It's probably gonna happen, but I just want to check here. So well, it works. Okay. Also, the getting stuck like that I should fix that as well. I should write that down as a bug. So now it should. So now when we exit, we saw that the save was saved properly there. Yes. But now if we go in here, but it was actually stored though, and we exit here. Did we get leaks? Yeah, 2 leaks. Yeah, okay. Yeah, okay, so it's not stored. That is curious. So now it's off. We turn it on. We go back up. Oh, it's not restored. I'm pretty sure this worked before. Okay, maybe I just didn't check it. All right, so apparently that doesn't work. Let me check this again. This stores on transition, yes. And then it also stores on save. That's the difference now, I think. It stores on save. But those entities should not exist anymore, so it shouldn't go through them. And clear it out. Wait a minute. When we save, so here, when we do a save, we're creating a temporary save thing here. So we're updating with the latest states here, okay. And then we also take this if we have a game temp save. Well, that should be the case. We should have a temp save here. And then we save that. Okay. I don't see anything wrong with this, though. And then we also call it over here. Wait, this is the same thing. We also call it over here. No, this is save. Yeah. Wait, this is also save. Oh, what the hell am I doing? This is the thing. Yeah. So we also call it here. That's when we do a transition, right? Is this where it goes wrong then? No, because let's just do a test. So let's just not store devices here, because I'm pretty sure this is what we had before, and it did work for the transition, but it did not work for saving if you don't do a transition. So yeah, we do this, we go up. No, it still doesn't work. What? I'm pretty sure this worked before. Well, I guess it's good because now we know that this is not the issue. What the hell? Yeah, we actually do have a string arena. Anyway, we store the thing before removing all entities and stuff. We store the state. But then we load with the same save file. Oh. Okay, that's probably the issue. So basically it's loading the save again. Okay, but okay, so what if we set this to null, and if it's null then we don't do that? I still want to do this though, I think. Yeah, we still want to restore. Maybe, no, not, we don't want to restore the primitives. This, we only want to do this on the load itself. Like, we only want to do this like basically on the initial load. But then down here we do want to do restore devices. All right. Okay. Yeah, so now you, well, okay, you can be nullable, but here we don't actually want to call this, like when we transition, we don't want to use the save. Okay. So when we load it initially, we do a full, we load using the save. Yeah. And then we also call restore devices, which uses the save as well. And then later on, we now should have the save populated, and when we do a transition, we call this with null here, so that we don't load the save again, basically, because we don't need to do that. This should all be in memory saved anyway. So maybe that's the bug where the quests reset on transition. Yeah. So the dialogue should also be reset. Okay, maybe that fixed that bug actually. And also you should have gotten like restored heart on transition as well. And also reset the gems to back to what you had before. Okay, so that should all be fixed now. And what the only thing we do on a transition is restore devices now. Alright. Okay, so let's try that. So this should still... actually I want to do one more thing. Store devices. We need this again. Yeah. We need to update those again. There we go. Do this, we go up again. Okay, now it's the state is restored. Very nice. It keeps the state. We close it. Okay, so we open it, we exit there, we enter again. It's still restored. Nice. And if we check the save, it's saved there. Alright, so now let's go up to the other place. Over here. We load this in. We do this. And we go out. Whoops, I died. Okay, let's just load in again. Okay, so oh yeah, so because I died, it crashed and it didn't actually call save, I guess. But let's go out, let's go back in. And there we go, now the state is actually saved. Also, let's just quickly, well, we already tested it, so I was gonna add a new room over here, but yeah, that's that works really well. Okay, so yeah, this the persistence works very well actually. so now, yeah, so now this, basically this area is sort of blocked off. So the idea is that you won't be able to open these until you have the upgrade up here. So you start out here, and then you go all the way over here. This is blocked off, so you're like, oh, it's blocked off, okay. So I'll go over here, you go over here. Now the idea is that this area should also be blocked off, and then there's a connection over here. So it's blocked off with the same thing. And then you go up here, and over here. And then this area is also blocked off, as you can see here. Alright, and then this area is also supposed to be blocked off over here. And you can go over to this area or to this area, but then when you go over here, I suppose we could block maybe over, like over here or something, I don't know, just so you don't go all the way over here and it's blocked here, let's say, and then you have to go all the way back. That's a bit annoying, so probably want to block off earlier than that. Okay, but then you go up here into the upgrade room, and you grab the upgrade. It's gonna basically, the idea is it's gonna sort of have a door here that's gonna be closing in on you while you enter the room. So once you've entered the room, or maybe even, okay, maybe like this, like let's say we have an entrance. It's gonna be sort of blocked off like this, but then over here is gonna be a door like this. Oh, this is the tile set part, but yeah, there's gonna be a door there. Let's go back here and we put a door in. So there's the door. Okay. And the door, this is actually going to be open at the start. So if we play this scene now, it's actually open now. So you go in here, and the idea is that, wait. Oh. Okay, I know the solution to this problem. This door is still like in the collision group. I know how to fix this issue because we just solved it in another way right before. So we have to call handle state change when we sort of initially create the device, I guess. Well, I mean, yeah, this is going to be the entity, and then we can call, we can import s device system handle state changed. Now the device type we need to grab. Oh, that's gonna be a registry. Alright, just get the device type on entity. And this should be false. And we should have t, yeah. So we handle the state change there. So that will handle any kind of shenanigans going on there. We should actually do this on every device. So we probably want to just call this at the end of this part here, actually. And this is already, we need m device type here. Yeah. All right, so we actually do that. All right. Right, okay. So let's try this again now. So now it should be open and we should be able to go through it. No? Wait, why is that? The state is open. Hang on. Yeah, so it should be removed from the group. Because we're adding it here. And then we're calling handle here. Right? So that should remove it. Oh, I see. So the state maybe hasn't changed. I see. I mean, I guess we could just force a state change, I guess. I'm just thinking about the repercussions of that. So, so from door, we're calling init device here. I mean, what we also could do is we could just set this to true, so it's always true for doors, I guess. At the start, it should I think it should be true for everything, I guess. So the state change is true, but it's always going to be called anyway at the start of the init device or at the end of init device. I mean, which doesn't care about activation, so that shouldn't be a problem. It should just be that. But now we have to be careful about what we're doing in handle state changed. It's a little bit of a multi-purpose function. So yeah, we might break it out later into separate parts, but which is going to be like one part for things that are going to update the internal entity and other things that are going to update other entities based on what's happening there. All right, let's see now what we're dealing with. All right, it's open. Okay, now we can go through it. And let's test just in case. We set it to be closed. And it's closed and we can't go through it. Okay, cool. Alright, so back to what I was saying here. The idea is that you go into this like upgrade room and you see, okay, I can't go over here. Maybe this should be like a closed door, I guess. Yeah. So let's make this a closed door. Over here. So this one is closed. Right, so you go up here. And it's like, it's closed here, it's open there. So you go through the open door. Now as soon as you go in here, it's gonna close behind you. So you can't go back. So for that, we need a different type of, I guess, logic entity. Pressure plate, or well, it's not really gonna be a pressure plate. It's more like akin to a laser detector where you cross a line or you collide with a line which is gonna trigger this. I guess it's gonna be crossing at this point because you want the player to be fully at the other side before you close the door. So if you stand over here, for example, we won't close the door until you're over here. It's gonna close the door. So that's gonna be some sort of thing there. I mean, what we also could do is just have a collision-based thing, and once you collide with it, which we just place at the correct place, it will collide with the player at the correct place, so it will trigger the closing of the door. And since the door is basically immediately gonna be collision like added to it, you're not gonna be able to like, oh my god, it's closing, and then jump back through, because it's immediately gonna close on you, so you can't actually go through it like that. Alright, and then it's gonna close behind you, and then you're gonna see, also when you go in here, the first thing basically you're gonna see is these things, and then to the left you're gonna see, oh, it's a shiny, so that's where you pick up this sort of device that we have here. So you get this device, and then you're gonna be able to sort of learn how to use it here to solve sort of like a, well, it's gonna be a very easy, I guess, puzzle to solve, maybe fight a few monsters along the way, and then at the end you're gonna get over at this side where you have to use this to open this door, and then you're back out at this point here, and you can go back, and then you have access to all these places here. You can go over here, and now you can open this door. So there's going to be something to open here, and so on. So then you can access basically everything in the dungeon. Then you can access this part, which just goes up to some treasure up here. You can access the boss room. You can access this part, which is also like a treasure room. You can go down here, access this part, and then go back up down here, unlock this part. Maybe, yeah, maybe we'll change how this works here, but yeah, you will be able to unlock that. Maybe actually there could be a toggle here that actually enables the toggle, which in turn enables the door. Actually, I'm not sure how that will work, because that's going to be an entity that is not yet saved. Or, I mean, not saved, not yet, like, created. And we're gonna need some sort of scene cross scene activation happening there. If we want to do stuff like that. If you want to have a toggle that actually activates something in another scene. Yeah, I don't know. Because the idea is maybe here we have, since we have this door here, and that's just to make it more like, yeah, you can't access this area at all. But then if you go over here, how would you get it back up? Maybe we put a similar door here. We put a toggle here that actually activates like both of them. I don't know. But then that requires also the toggles to be changed, like they can have several targets, and we don't really have support for arrays right now, even though it should be probably possible. I mean, of course it's possible, but it's probably not that hard to implement. Well, actually, it's gonna be a bit of UI stuff that we need to add for that. Like, but it's not gonna be that much of a problem, I don't think. But anyway, and then there's gonna be also a little bit of treasure room over here that you can access now with the new thing. So basically a bunch of new areas that you can access to get some stuff, and then yeah, but then that's basically the first area. That basically pre-alpha demo is then gonna be sort of complete, and now I guess you can go back to the village and turn in some quests and stuff. Maybe there's a fetch quest, you have to fetch an item that's only available down here, or I don't know. Then maybe we want to have like a map system. I'm pretty sure we want to have a map system. I'm not sure exactly how it will work yet, but that seems to be a good thing. But I'm not sure, like, maybe that's good to think about with this first pre-alpha demo. Like, how will the map work? Because the sizes of these rooms can be arbitrarily set, and it's not like, I like when maps are grid based, but I'm not sure if that's how we're gonna do it. I mean, Hollow Knight has more of, not really grid based, it has more of a, yeah, just, you know, a map on paper or whatever. I don't know what to call it. It's just like a real map, and then you can see your position, I think, on that, if you have the compass maybe, or I don't remember. But I'm not sure how we're gonna do it, so it would be cool to have something like that. I mean, you could just generate a map, I guess, from, but that's gonna be maybe, yeah, I don't know. We'll think about it. Yeah, we have the boss also left to do as well. And this area, probably maybe some new enemies in this area here. But yeah, so there's a little bit stuff to do here to make the pre-alpha demo sort of complete. So let's see, what is the, well, it's gonna be, so yeah, the next implementation is probably gonna be this toggle thing here, so we can actually make this room possible. Also, I want to also add more puzzle type elements. Like right now we only have this load, like toggle thing, and we also have buttons. So actually this could be a button that enables this door over here. So this could be like just connected to this. So you basically just press this button and we open the door, so you don't have to like use the logic, like you don't have to use the device to open it or something like that. So that could also be something. So then you learn that, oh, this is a button and you have to press it to open this door. But then maybe we have one of these and you have maybe, I don't know, a door. Well, I'm not sure actually how to do this. Oops. 1, 2, 3, 4. 1, 2, 3, 4. So you stand on top of here, then you have 3 height and 4. So you can jump up there. I don't really like the layout here. Wait. Yeah, the door, this could be over there. So you can still jump on top of that even though the door is that low here. You activate that, then you can 1, 2, 3. Yeah, you can wait. Yeah, you should be able to jump up there. Yeah. So let's say this is opening that. Okay. Let's just test that. So go over here, you can jump up here, but you can't go up. You open this up like that. So then you learn basically, okay, you get the item here, and then you have to use it to get past over here. Yeah, the open and close animation, if you toggle this quickly enough, it looks a bit weird, but I don't care. Okay, and then you solve a bunch of puzzles or fight monsters or whatever over here. You go all the way, and then you get all the way back over here, and you open the door over there. Now, since we don't have buttons yet, it's not spawning there, but we have to add the button as well. And then I want to add, as I said, I want to add more puzzle type elements, but probably not going to be like in the real game. It's probably not going to introduce all sort of weird puzzles in this. But we probably want to have this as sort of maybe like a playroom for different puzzles. Maybe, so we can experiment with that. One thing that I'm thinking of is having like reflectors. So the beam is not a light beam, but it's sort of, it could be, you could have these special like reflector surfaces that reflects in 90 degrees basically, the beam. And it will like shoot up like this, and you can have several the reflectors placed around, and it will like move like that. And then maybe and then you can have like moving devices as well, so that the reflectors might move and target different things. Maybe you have a gear type thing that you can turn, and so then you move something else. Yeah, something like that. We'll see what we'll come up with here. But yeah, that's gonna be it for this time. I have to go to sleep here. So thanks very much for watching, and I'll see you later. Have a nice day, and bye bye.